first example just says graph 2 cycles of y equals sine x. That is just your parent function. Hopefully you did that. Now that you've done that little packet, it'll be easy to remember what to do. And it also tells us to use radians. There is no horizontal shift, so it has to tell you. Sine starts in the middle, and it goes high, middle, low, high, as long as it's positive. So we're graphing 2 cycles. So from 0 to the 5th is going to be 2 pi, and then we're going to have 4 pi, and then halfway in between, so we have pi over 2, 3 pi over 2. So you can think of it as you're going by a half. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 3 pi, 7 pi over 2, 8 pi over 2. Or you can just keep adding and dividing by 2. Either way will work. So, the amplitude is 1, so we go up 1 and down 1. So high, middle, low, middle, high, middle, low, back to middle. So here is the graph, 2 cycles of a sine graph. Remember, yes.
So it's fine if your fractions aren't simplified, like from the graph?
No. Fractions must be simplified always.
So 8 over 2 has to be changed to like 4 pi?
Yes.
On the graph then?
Yes. If not, it'll be a point off. Every time you don't simplify, it's at least a point off. If not more, depending on if it's the only thing that you're doing. Always simplify, okay? No matter what, you are always simplifying. If not, it'll be at least a point off, if not more, depending on what the question is. All right, so now if we're just answering the question, sine of pi equals. Now we know sine of pi equals our unit circle. But if not, we can also get this answer from this graph. We go to sine of pi, this is the graph, sine of x. Sine of pi is going to be equal to the y value, which is 0. Or again, we know on our unit circle what sine of pi is. Sine of 3 pi over 2. We know on our unit circle, bless you, here's 3 pi over 2. That would be negative 1. Well, it should match on our graph. At 3 pi over 2, this function equals negative 1. Sine of 5 pi over 2 is more than 1 rotation on our unit circle. So when we look at this graph, here's 5 pi over 2. That's going to be equal to 1. Now, if we asked sine of pi over 5, something like that, that's not something we can get from our graph. That would be using a calculator to figure out what that is. All right, so using this graph, sine of x equals 1. So we're going to be solving for x. It says sine of x equals 1. So this graph right here that is being shown, this is the graph sine of x, the curve, and we want to know when is that equal to 1. So here's 1. So we have the black graph that's already there, and the blue graph I just graphed. Yes?
Wait, so why can you not do sine of 5?
All right, so sine of x equals 1, and we want to know only between 0 and 4 pi. So it gives us this increment of 0 to 4 pi, because remember, this graph goes on and on forever to the left and the right, but it's telling us to only answer these questions on this particular interval. So we're only looking between 0 and 4 pi. So it says how many values of x exist on the domain given. There's how many? 1, 2, 3, 4, 9, 8. So I look. I'm only looking between 0 and 4 pi. So I look and see how many times does sine of x equal 1? 1, 2. Where do these values exist on the domain given? Well, it happens at pi over 2, and it happens at 5 pi over 2. So that would be at x equals pi over 2, and x equals 5 pi over 2. That's where it happens. How often do they occur? Okay, well, from pi over 2 to 5 pi over 2, subtract those two. That happens 2 pi radians apart, 2 pi units apart. And then what is the previous value in relation to the equation. So let's think back to, again, that's why we did that packet. If we think about 2 pi and we think about the function sine x, that is the period, okay? This number right here is the period of that function. So that is how 2 pi relates. How often do these values occur? They are going to occur every period. So sine x equals 1 is going to happen every 2 pi. So if we add another 2 pi, we get another answer. Add another 2 pi, we get another answer, and another answer. And it's going to keep going on and on forever. So answers are going to happen every period in this case because it is at a high point. That'll happen at a high or low point. Now once we get in the middle, okay, this anywhere from the top to the bottom, now the middle kind of has its own special characteristics, but anywhere between the high and the middle and the low, there's going to be something else that goes on.
Is it not right if like you put for the values, if you put like x equals blank comma blank, then you have to be like x equals blank x equals
Pi over 2 comma 5 pi over 2 is fine. Oh yes, that's a good question. So x equals pi over 2 comma 5 pi over 2, I'm fine with that. Okay? You do not have to write x equals every time. All right, now that same graph, we have this question right here. Where does the same things happen, but now our domain is negative infinity to infinity. So we've only graphed 2 cycles. We cannot graph the whole sine graph. It's asking, answer these same questions from negative infinity to infinity. Okay, so how many times does that happen? Well, remember this keeps going on and on, so it's going to happen right here. It's going to happen right here, and it's going to keep on happening forever and ever and ever. Okay, so how many x values? An infinite number. Infinite number of x values on this domain given. You're never going to stop having x values. So there is no way to physically write all of those down without writing equations. So where do they exist on the domain given? Okay, well, at pi over 2, at 5 pi over 2, plus another pi, plus another pi. So it's going to keep happening. It's going to happen at pi over 2, at 5 pi over 2, plus another 2 pi would be 9 pi over 2, plus another would be 13 pi over 2, and it would just keep on going forever. You can subtract 2 pi at negative 3 pi over 2, at negative 7 pi over 2, and so forth. So no, we cannot list them all, okay? We cannot just list them. We have to come up with something that's called a general solution, okay? So the way that we are going to express all of the solutions when this is our domain is called general solutions. Sometimes it asks for general solutions. What are the general solutions? Sometimes it gives you the domain of negative infinity to infinity, and that means find the general solutions, which means you're going to come up with an equation. And your general solution equation is going to be x equals, so you're finding all of the x values where this happens. We can't list all the x values. This problem, we can list the x values. The domain given was just 0 to 4 pi. We could list those very easily. Here, we cannot list them all. There are way too many for us to be able to list. So, it's x equals a value where it happens. You can pick any of those values where it happens. Pi over 2 is fine. 5 pi over 2 is fine. 9 pi over 2. I usually pick the one that's closest to 0 that's positive. It doesn't matter. It can be positive, negative. Infinite number of solutions. Every single one of you could write a different answer every single day, and all those answers would be right. Then you add the period. Okay, so whatever the period is, you have to know how to find the period. 360 or 2 pi over b for sine, cosine, secant, cosecant. 180 or pi over b for tangent and cotangent when we get to those. Okay, times n. N is the number of rotations that you have. And N, we are defining as an integer, which is going to be any positive or negative whole number. That's what an integer is. And again, we define N as an integer. So that's why we don't say plus or minus the period. Okay, we don't assign N to be a whole number. We assign it to be an integer. So when you write a general solution, and you might have more than one, sometimes you have more than one, that's what's going to happen when we get kind of in the middle of the high and the low. X equals, pick one of the values that makes the equation true, any of them, plus the period, so no matter what, the period will always be the same, and then just times N. So this is going to be some value, the period you have to find, and they have to match. If the period is in degrees, your value must be in degrees. If the period is in radians, then your value must be in radians. You can't mix match those, because then that's going to be wrong. Okay, not just a point wrong, that is wrong. You can't take pi over 3 and add 360 degrees to that. Those don't match. Okay, that's not allowed.
So when we write a general solution, do we as a variable?
And
So that it
could be. So, like this one would be x equals, so let's do it for this particular problem. Okay? X equals some value where this happens. Okay, so we're going to write a general solution for sine x equals 1. Some value where that happens, I'm going to say pi over 2 plus the period, which is 2 pi n. That is your answer for this question. Okay? We want to find where sine x equals 1 over the interval negative infinity to infinity. That covers everything. We could make 1 rotation, 2 rotations, 3 rotations, negative 737 rotations. Okay, we could do anything on that, and this covers all of the answers. This pi over 2, you could have written 5 pi over 2. You like that number better? Write 5 pi over 2 right there. You like 9 pi over 2? Write 9 pi over 2. But you don't want to ever repeat general solutions. So this particular one, because sine x equals 1, and 1 was a high value, so if it's at the top or the bottom of your graph, then you'll only have one general solution. When it's somewhere in between, we're going to have more than one general solution. But for a problem like this, there would just be that one general solution, and that covers all of the possible answers you could have. So general solutions, or a domain of negative infinity to infinity, covers, or is going to be expected to write an equation. And this x, this is the variable. It might be a theta, might be a capital R, okay? It's just whatever the angle is represented in the problem. All right, so let's look at this one. So lots of different questions. Some go back to just regular things that you have found before, and some are new things like general solutions. So it says graph one cycle, and we have to decide, is it degrees or radians? This right here, there is no degree symbol. Now there's a pi, that gives it away also, but that is not how you determine. There is no degree symbol. If there is no degree symbol, then we are in radians. Degree symbol means degrees, no degree symbols. Because that might just have a 3 right there, or it just might be a 1/3. That doesn't make it anything other than it still makes it radians. All right, so we graphed a few of these on that packet. So we would start here, and that would just be at 6, the opposite. Our period for this would be 2 pi over b, which is pi over 3. So 2 pi times 3 over pi, which is just 6. So does that mean if we start at 6, we end at 6? That doesn't make any sense, right? We add 6 to that, so we get 12. And then we add and divide by 2, we get 9. Add and divide by 2, or you can see that you go 1.5 each, so we can make that 7.5, or 15 over 2. It does not matter to me. We could make that 21 over 2, or 11, no, 10.5, 10.5. fractions or decimals, I don't care. If the decimals are exactly the fraction, that's fine, but if they're not exactly, then we don't want to write them. But again, 21 over 2, 15 over 2 is fine. Then we have our y-axis, still needs to be over here, wherever 0 is. This negative right here means we moved down 1. The 3 means the amplitude is 3, so up to 2 and down to -4. The cosine is positive. Cosine, positive starts high, negative starts low at our first critical value. So right here at 2, we're going to go high, middle, low, middle, high. And there is the graph of one cycle. All right, so now these just general questions. Find f of 6. That means find what the function equals when x equals 6. So we can just look at the graph. Here's 6, the function's equal to 2. 12 is on that graph. F of 12. We go to where x equals 12. What does y equal? 2. Easy. 10.5 is on that graph. When we're at 10.5, right here, we were at -1. Now, 0, 15, and 8. Those are not on our graph. But, depending on kind of how you can see this graph and what you know about sine and cosine graphs, can determine, okay, can I find that out with this graph, or do I need to plug it in? Either way works. You can always plug it back into the function. If it's a non-calculator problem, it will always end up being something on your unit circle that you can evaluate. So, f of 0. So let's just think about this. If this was 12, and this was 6, if I went back another 6, where would I end up? At 0. So if 12 is at a high, and 6 is at a high, then 0 would be at a high. So we can just say that's going to be 2. You can think of it just like that. Or if you want to draw more of your graph, you can draw more of your graph. That's fine also. F of 15. So when I look at these numbers, I should notice that 15 kind of falls in those numbers too. 6 plus 3 is 9, plus 3 is 12, plus 3 is 15. Now that doesn't go back up to the high, so it was high, plus 3 to low, plus 3 to high, plus another 3 to low. So we know that f of 15 would be -4. Okay, you can think of it just like that. Now 8 is a little bit trickier because we don't know. Here's 8 somewhere in here, right? And so it's somewhere down here. So this would be one we have to plug in. So -1 plus 3 cosine of pi over 3. 8 minus 6 is 2. So -1 plus 3 cosine of 2 pi over 3 is going to be -1 plus 3 cosine of 2 pi over 3 on our unit circle. Right up here, cosine that's going to be equal to -1/2. So we get -1 minus 3 over 2. So if I make that 2 over 2, I get -5 over 2. -5 over 2, -2.5, whichever one you like. Doesn't matter to me. So again, you can't always just look at the graph. Sometimes you have to plug in. You can always just plug it in. Plugging in will always work. If I had said f of 8.2, now that turns into a calculator problem, which we will do these with the calculator also. Okay, so that's just general. Find what the function equals when you plug in a number. The other part of that is the general solutions. That's the new part. So we want to find the general solutions, okay, could just be one, could be more, for the function equals 2. So notice the difference. The function equals 2, or f of 6 equals what? There's a difference right there. Okay, be sure you know the difference between the two. So if I say the function equals 2, I want to know the general solutions for that. So I look at my graph, and I see what happens. So 2 is up here at the top. And I can see that in one cycle, okay, that happens really once. So it happens at the beginning of the cycle, and then it happens again at the next beginning of the cycle. So I'm just going to have one general solution. So my general solution is x equals an x value where that happens. So an x value where that happens is 6 or 12. Pick either one of those. I usually pick the first one that's on my graph, whatever it is. So the x value where it happens plus the period. We already found the period. 6n. That's it. That's your general solution. 6 plus 6n. Could we have just said 6n? You could. Okay? I could use 0, 6, 12, negative 6, negative 12, negative 36, 36, anything. Because this value happens every 6 radians. Okay, so that could be any of those. I don't want to write another one. I don't want to say x equals 12 plus 6n because then that repeats. Because what if I plug in a 1 right here? If I do one rotation, then I get 12. So I don't want to ever have repeating general solutions. If it happens at the high or low value, and we aren't going to always graph it. Right now we're graphing it just to remind you what happens, because sometimes you have to graph it. But these are not going to be just graphing the whole unit. But for right now, we are looking at those. All right, f of x equals -1. So if I look at that one cycle, there's 2 different places where the function equals -1. Are these 2 values the period apart? They're half the period. Okay, so we can either write 2 general solutions or we can half our period. Either one works. So where does f of x equals 1? Well, one place is at 7.5. So if I say x equals 7.5 plus the period n. 7.5 plus 6 does not take me to 10.5, so I'm going to write another one. X equals 10.5 plus the period n. So I have 2 general solutions right there. Now, some of Meredith said we can take half. So, or if you recognize that if it's on the middle, okay, only on the middle, not in the middle, on the exact middle, we could have just said x equals 7.5 plus 3n. Would that work? That would work because of our graph right here, 7.5 to 10.5, 13.5, that would have worked. It does not matter to me which way you do that. I tend to stick with a value plus the period n. Then you don't have to remember, well, can I cut it in half? Can I not cut it in half? Who knows what to do? If you just always stick with a value plus the period n, then you don't have to worry about repeating answers. Now, when we get to cotangent and tangent, those kind of have their own special situation because they happen more often than sine and cosine. But as far as sine and cosine go, x equals a value, or theta, whatever the variable is, a value where it happens plus the period n. So depending if it's at the top or bottom, you only have 1. If it's directly in the middle, or anywhere in the middle, you're going to have 2 of those values. All right, another one to graph. So degrees or radians. Hopefully it's very apparent. There's a degree symbol. So we're going to use degrees. Okay, and it says graph 1 cycle. So we start with C value. That's the opposite. So that's -10 degrees. We always need to find our period. Our period is going to be 360 over B. So 180 degrees. So from -10, we're going to add 180, which takes us to 170. And we can either divide 180 by 4 and figure out how far we go, or add and divide by 2. So 160 divided by 2, 80. 70 divided by 2, 125, 250 divided by 2, 125, or we went plus 45, plus 45, plus 45, plus 45. Either way works. All of those should always be the same distance apart. If they're not the same distance apart and they don't go from smallest to largest, you did some math wrong. Okay, which is very easy to fix. Our y-axis goes wherever 0 is going to be. And we have a amplitude of 1, and we moved up 3. So, again, if you like that dashed line right there, draw that dashed line. I sometimes like to draw that dashed line right there. And we just go up to 4 and down to 2, because there was just a 1 in front of the sign. This was our A value, our B value, C value, and D just happened to be out in front. It can be in front or the back. And sign starts in the middle. It's positive, so it goes high, then back to middle, then low, back to middle. So there's one cycle of that sine graph. So find f of 35 degrees. We look at our graph, 35 degrees, it's equal to 4. Not 4 degrees, just 4. The only place that will have a degree or a pi is going to be the x-axis. The y-axis isn't going to have that. The only time the y-axis had that is when we did inverse sine and cosine. We're not doing inverses. F of 125. Happened to be on our graph. F of 125. We can see right there, it is 2. Now, let's say I didn't ask you to graph this one, and I asked you to find these two. Two different ways. You could graph it, find the value, or we could have just plugged in 35. 35 plus 10 is 45, times 2 is 90. Sine of 90 we can find. Sine of 90 is 1, plus 3 is 4. Either way works. Plug in, or look at the graph if you have a graph. Now, the general solutions. Okay, these are finding all of the answers that could make this happen. Over here, you're only going to have one answer. It goes back to, is it a function? There is only one y value for each x value. But there can be a lot of x values for one y value. Okay, just goes back to your vertical line test. So when is the function equal to 6? Never. So what are the solutions? There aren't any. No solution. Very good. Okay. F of x equals 4. That does happen. In one cycle, it happens once. So we only need one general solution. X equals the value where that happens. That's at 35 degrees. Plus the period. The period we found already to be 180 degrees. N. So there's your general solution for that. Okay, we only need that one. We don't need to write anymore. We have one because it happens once in one cycle. Always thinking about one cycle. One cycle is the period. How many times does that happen in the period? So this unit is going to be very repetitive.